Good morning, students. Welcome to class on Thursday. The week is almost over, so hang in there and please work hard today during the class period. Let me quickly prepare you for your quiz. So I'm not uh, uh, going to keep talking. I'm going to pause here. Actually, I'll make some announcements while you're getting your notebooks out. So get your notebooks out. I'm going to tell you what's going to be on the quiz tomorrow. So get your notebooks out and listen while you're doing that. There will be a test in here. Looking for my notes. Hold on one second. There will be a test in here next week. I'm not sure what day. Usually I do Fridays. Probably will do a Friday, but I'm just not sure yet. So there will be a test next week. You do not owe me homework unless you've not turned in homework from this week. But last night, Wednesday night, you did not have homework. And then Ashley, you're the only one that owes me assignments from like a couple weeks back, and those will turn to zeros on Friday. I'm sorry, I've got to get these in, okay? And you've had plenty of time, you know that, so nothing personal, but they will turn to zeros this Friday. And by the way, unless you guys share grades, you know that one of you did not do well on this past test. You are allowed retakes. I talked to Mr. Harmon about that, and so if you'll email me and request a retake, I can get a different test into your hands, and so let me know about that, okay? Usually I give you a week to take a retake, but because I'm just now announcing it, if any of you who scored less than, what is it, 70, I believe, if any of you want to retake, it has to be by next Friday, okay? I think that's basically it. Get your incompletes turned in, grab your notebook. Here's the assignment for today, by the way, so why don't you copy that down first. Today we're doing page 390, numbers 10 through 29. You will get by far most of it done in class, if not all of it. And now let's get into your quiz. Please don't try to write these definitions down. They're in your notes, okay? I just copied and pasted these. I mean, I suppose if you wanted to try to copy them down, you could, but I'm not going to wait for that. So here we go. You need to know the definition of ratios. Write that down. You need to know the definition of what a proportion is. All of these will be fill in the blanks. You need to know what similar polygons are. That definition will be on the quiz. You need to know what you need to know the angle similarity postulate, right there. And you need to know the side similarity theorem. By the way, if you want some help, ratio would be less than 7.1 nodes, proportion would be 7.1, similar would be 7.1, angle similarity would be 7.2. This should be, and I'm going from memory, I hope this is right, this would be 7.3. Now if you want to pause the video, do so, because I'm going to the next page. So you probably want to pause the video, and don't try to copy the definitions down. These are right in your notes. I cut and pasted, but I'm going to move on. So pause the video if you need to, until everybody's done copying these terms. Again, I would not try to write the definition. You're going to waste way too much time. Okay, moving on. Pause the video if you need to. Also, you'll need to know the side or the side angle side similarity. I'm pretty sure that that was also 7.3. So look in your notes at 7.3. And now I'm starting to have my doubts here a little bit. Let me look back here. I guess I need to be super organized. And so I apologize for this. I know this is poor teaching. I will admit that, and I apologize. Okay, let's see, 7.2. Okay, let's go back, and I'm really sorry. This was 7.1. That's correct. This is 7.1. That's correct. Similar polygons was 7.2, so please fix that very quickly. Please fix that. And then we have, let's see here. We have angle is 7.3. This would be 7.3. Sorry about that. And this here would be 7.4. This right here would be 7.4. And then these next three right here, we learned yesterday, all three of these here would be in less than 7.5. Okay, 7.5. So pause the video if you need to. Again, I would not write down the definitions or the whole theorems. You've got them in your notes. I would just write down what you need to study later, okay? So pause the video if you need to. I'm moving on. Okay, let's talk about the problems that will be on the quiz. Guys, are you starting to figure this out now? It's not like bridge math, Megan. It's not like Algebra 2, Ashley and Kate. Tara, I've never had you before. It's not like that where I can say we're going to have graphing polynomials, graphing quadratics, graphing linear equations, slope-intercept form, double-intercept form, factoring trinomials, factoring binomials. It's not like that. They give you these theorems, these postulates, these corollaries, these definitions, and they give you problems and they attack it from all different angles, okay? So what you're going to have to do is study your homework. Now, I'm not saying redo every problem. That's insane. I'm saying, A, get your homework done in class today so you can then spend your time tonight studying for your quiz. And then, excuse my language, but study your tail ends off, okay? Study, study, study. Make sure you know all of these. Fill in the blank. All of these on the past 2 pages, this page, and this page will be fill in the blank. And then study the homework problems from lesson 7, 1, 2, 3, 4, and 5. Look those problems over. You should be able to look at a problem and say, yeah, I know how to do that. Or look at a problem and say, I'm clueless, man. And that's the one you redo. You pull the video up on your computer and you study. It might take you an hour. It might take you 30, 40 minutes. But that's what it's going to take if you're going to do well on this quiz. Okay, guys, you're seniors, you're big, you're big adults, are about ready to step into adulthood pretty soon here, and that's what you're going to have to do, okay? So I'm not being lazy and not being willing to give you all the problems that'll be on the quiz. They attack these things from so many different angles. You're going to have to study your homework from 7.1, 7.2, 7.3, 7.4, and 7.5. Now your homework from 7.5 is right now. Here it is. So I'm going to start the help video. I don't know if you guys watch it through and copy it and then go back and study it. I don't know if you do it on your own, then watch the video when you get stuck. However you do is between you and Mr. Harmon or your sub. Mr. Harmon's probably not there today since the state tournament. However, I'm going to go ahead and start now with that help video. So here's problem number 10 right here. Okay, here we go. Problem number 10 says solve the proportion. You should be really good at these by now. Multiply 3 times m, that would give you 3m. 2 times 36 would give you 72. Divide both sides by 3, and your answer is 24. Moving on to number 11. Number 11, we cross multiply. 2 times 5 is 10, and t times 12 is 12t. Now divide both sides by 12 and you get a fraction. You get 10 over 12 equals t. Do you see how I did that? Divide by 12, they cancel. Divide by 12. Now if you reduce that, you get 5, 6. If you want to record that or write that as a decimal, I have no problem. The decimal would be 0.823 repeating. Okay? I don't care which answer you have, but don't use this for your answer. That's not reduced. Use either 5, 6 or 0.83 repeating. And I did this in my head. I hope this is right, 0.83. You have calculators, so you can check all that out. You would type in 5 divided by 6. All right, move on to number 12 here. Number 12. All right, y times 7 is 7y, and then 21 times 18. Well, I better do it off to the side here real quick. 168, 21. I'm getting 378. 378, and let's see, and 7 would go into that 50, let's see, 54 times. So divide both sides by 7 and y would equal 54. All right. Okay, moving on to number 13. Let's cross multiply, shall we? 3 times r is 3r. 4 times 27 would be 108. And we divide both sides by 3, and you should get 36. Moving on to number 14. Okay, here we go. Now, the book says, let me get on the right page here. Sorry that I'm not. All right, number 14 through 19. 14 through 19 says find the value of the variable. Now listen, we had a theorem, and you learned it yesterday. The theorem said if you have a triangle, and you have a line drawn inside that triangle that's parallel to the other side, and we can see they have parallel symbols, then we have proportional sides. We can write 7 over x, this part here over this part here equals this part over this part. So 9 over 16. Cross multiply, you get 9x equals 42, carry your 4, 112. Divide both sides by 9, and whoa, you will get something kind of weird. Let me look in the book here. They're getting 14 exactly. Could that be right? That could not be right. Let me make sure I copied this correctly. Oh, I apologize, students. This should be 18. This should be 18. Sorry about that. So 9 over 18. Sorry about that. Let me cross this off. So 56, 126. And now you do get 14. So the answer is 14. 126 divided by 9 is 14. So whenever a line drawn inside the triangle is parallel to this side here, it splits these other two sides up into proportions. All right, number 15, same thing. You've got a line drawn inside the triangle that's parallel to this side here. So whenever that happens, we know we have proportions over here. So we can say 21 over 7 equals y over 6. Now again, this only works, what I'm doing only works when you have a line inside the triangle parallel to this other side. Okay, we're going to cross multiply. 7 times y is 7y, and 6 times 21 is 126. Now we're going to divide both sides by 7, and you should get 18 for your answer. 18. Okay, moving on to number 16. Again, same thing. Here's my triangle. I'm going to trace it for you, although I know you can see that. You're not blind. Y'all can see that. But there's my triangle. Here's this side here that's parallel to this side here. Whenever that happens, we have proportions. Now, I don't care if you put p over 15 and 6 over 20, or if you do it the other way. I'm going to do it the other way. I'm going to put 15 over p and 20 over 6. Now cross multiply. 20 times p is 20p. 6 times 15 would be 90, I believe. Is that right? 90. Divide both sides by 20, and you should get 4.5 or 4.5. So you could have 4.5, or you could have 4.5, or you could have 9 over 2. Really does not matter to me. Hold on, something's not right. I mean, yeah, 9 over 2. Yep. Okay, so there we go. All right, moving on to number 17. Again, same thing. You've got a triangle with a line inside it parallel to this side down here. Whenever that happens, you know that you have proportions. So we can say 5 over 15 equals q over 24. So let's cross multiply. 15 times q is 15q. And 5 times 24 is 120. Now, I believe you'll get 8. Yes, that is correct. 15 goes into 120 8 times. So the answer is 8. Cruising right along. All right, now be careful on this one, students. Please be careful. Now watch this. Yes, we have a triangle. Obviously, you can see that. You can see that we have a line here parallel to this line here. So we know we have proportions. We did one like this in your notes yesterday. The only problem is if I put 20 over 12, I don't know what to put over C. Look, I don't know what the length of this segment here is. So here's what we're going to have to do. Now watch this carefully. Instead of putting 20 over 12 or 12 over 20, look, we know, did not mean to do that, not even sure how it happened. Here we go. Now watch this. We know we're looking for C, right? That's obvious. So why don't I put 12? See this 12? I'm going to put 12 over, not 20, but 12 over 32. Dude, Mr. Earhart, where'd you get 32? The whole length. You can do that. That's totally fine. I mean, if these two segments here are proportional to these two, then the whole length with one of these sides is proportional to the whole length over here. Now, Mr. Earhart, why did you use 12 over 32? Why not 20? Because I'm looking for C. And which segment over here goes with C? This one does right here. That's why. Now, I'm going to put 12 over the whole length. I can do that as long as I put C, which corresponds with 12, over the whole length. And what's the whole length over here? 24. Now let's cross multiply. 32 times C is 32C. 12 times 24, I have no idea. 24 times 12 would be 48. 24. I'm getting 288. Hopefully that's correct. And then divide both sides by 32, and the answer should be 9. And yes, it is. That's correct. 9. Okay, moving on to number 19. Oh, good. We get to practice another one like this. It's so important. All right, look, we know we have a triangle. We've got a side here, or a segment inside the triangle parallel to this side here. So I could put 12 over 32, but if I do that, then I've got to put z over question mark. I don't know what this length is right here, so that's not going to work, okay? So we're going to have to put either 12 over the whole length or 32 over the whole length. Well, I'm looking for z, and z corresponds with 12, so I'm going to use 12 over the whole length, and the whole length is 44 because this is 12, this is 32. If you add those two together, you get 44. Equals, and now what corresponds with 12? Z does. So z over, well, the whole length here is 44, the whole length here is 55. Now let's go ahead and cross multiply. 44 times z is 44z. Wow, let's see, it would be at 550 plus 110. I think it's 660. I did that in my head. Let's check it real quick. 55 times 12 would be 60, 60. Yeah, I got it right. Miracles still happen. All right, so 12 times 55 is 660. Divide both sides by 44, and the answer to 19 should be 15. And let's see if that's right real quick here. Let's see. 15, 60, 60. Yep, that's exactly right. So the answer is 15. Okay, moving on to number 20. Now, number 20 is different. They're asking you. Ooh, I should not have done that. I'm not sure why did I put parallel symbols on all those? Good, I did not. Okay, there should not be, if you'll look in your book, you'll see this. There should not be any parallel symbols right here, okay? No siree. No siree, Bob. All right, now, here's what they want to know. Please watch this carefully. They want to know, is this segment right here parallel to this segment here? Well, here's what you learned. You learned a theorem yesterday that said, if these two segments here are proportional to these two segments here, then these two lines will be parallel. So let's find out. Let's put 16 over 4 equals 8 over 2. Now let's reduce. You get 4 over 1, and you get 4 over 1. So we get out two equal fractions. So yes, they are parallel. All right, 21. Now look, this line right here will be parallel to this line here if these sides are proportional to these sides. So let's find out. Let's put 12.5 over 5 equals 10 over 4. Now, I've taught you this before. Whenever you have a decimal, you want to move it to the end, and however many places you move it, you've got to move the decimal down here the same amount of places. So I'll move the decimal one place. That's 125. But if I move the top decimal one place, I got to move this decimal one place too. So I have 125 over 50 equals 10 over 4. Now, if you reduce this right here, well, let's start with the 10 fourths. That's easy. 10 fourths would be 5 halves. So 10 fourths is 5 halves. Now, let's see. This is not going to give you, I don't think, let's see. It might. Let's see. All right, 5 would go 50, 25. Yes, we can reduce both of these by 25. 25 would go into 125 5 times, and 25 would go into 50 twice. So yeah, that does work. So this reduces to 5 halves also. So yes, this line here is parallel to this line here. Yes, yes, yes. All right, number 22. I'm not sure why I drew parallel lines on there again. I didn't do this late at night either like I usually do. All right. So, fix that real quick. And here we go. Well, this line here will be parallel to this line here if I have proportional sides. So let's find out. 35 over 16 equals 34 over 15. Now, the only number that goes into 15 is 3 and 5. And 3 and 5 won't go into 34, so this can't be reduced. So I don't care if this can be reduced, it'll never equal this over here. So these two fractions are not equal. So no, this line is not parallel to this line here. All right, number 23. Again, Mr. Earhart has at least consistently gone brain dead. At least I'm consistent with my mistakes. We should not have parallel symbols there at all, okay? I think I got so used to drawing those on the previous problems, I just kept doing it. All right, so here we go. Okay, this line here will be parallel to this line here if these segments are proportional. So we're going to put 12 over 9 equals 20 over 15. Well, 3 goes into 12 and 9. I can reduce that down to 4/3. 5 goes into both of these. This reduces to 4/3, so the two fractions are equal. So yes, these two lines here are parallel. Yes. Okay, moving on to number 24. Now, the third theorem we learned yesterday was this theorem right here. We learned that if this segment here is congruent to this segment here, then that means this is the midpoint of this line here. And if this segment here is congruent to this segment here, then that means this is right in the middle of that line over there. Now, anytime you have a line drawn in a triangle, like this line right here, and this line hits at the midpoints of both sides, then A, this side here is always parallel to this side, and this smaller side is always half of this side. Or you can say this longer side is always twice as big as this side. So, if this is 4, what does x have to be? 2. Half of 4 has to be 2. All right, number 25. Look, same thing. See how this segment here is marked congruent to this segment here? So that means this point right here is on the middle of this line right here. Now, see how this segment here is congruent to this segment here? That means that this point right here is on the middle of this line right there. So, this line right here is connecting the midpoints of these two sides. So this here is always half this longer side here. So if this is 11, then A has to be what? Well, A has to be 22, twice as big. All right, and by the way, how can you get confused which one is half and which one's twice as big? I mean, look at the picture. This line is always going to be smaller than that side, so you know the smaller side is half this side. You know the longer side is twice the other side. So, shouldn't be too hard to figure out. Okay, number 26. Let's see if we can't solve for B. All right, I'm not sure what's going on here. All right, notice again, I know I'm being super redundant, but I'm going to drill this into your head. See how this segment here is congruent to this segment here? Well, that means this point right here is in the middle of this whole segment. Now, see how this segment here is congruent to this segment here? That means that this point right here is in the middle of this whole line. All right, so anytime you draw a line in a triangle that connects the midpoints of these two sides, this smaller length is always half of this length, so B would have to equal 9. Okay, moving on to number 27. Okay, now they're using numbers now, so what's the big deal? How long is this segment here? 7. How long is this segment here? 7. So they're equal. So we know this has to be the midpoint on this segment right here. That's the middle. All right, this segment here is 8. This segment here is 8. Okay, so we know that if this is 8 and this is 8, then this point here is right in the middle. So this point right here is the midpoint of that whole side right there. So I've got a line that's drawn right here on the inside of a triangle that connects the midpoints. That means this smaller side is going to be, well, let's look at this. The bigger side here is going to be twice as big as this side here. So C has to be 10, twice as big as the other side. Okay, let's move on to number 28. Again, we know that this side here is congruent to, or this segment here is congruent to this segment here. So that tells me that this is the middle of this whole side over here. This segment here with 2 slashes is congruent to this segment here. So that tells me that this point right here is on the middle of this whole side over here. So anytime a line is drawn on the inside of a triangle that connects the midpoints of these two sides, we know that this here is always half of this. So if this long side is 1, what's half of 1? Well, you could say 1/2, or you could say 0.5. Either one is fine. And last but not least, this is not a long assignment. Ladies, you almost said ladies and men. I'm so used to having co-gender classes. Ladies, you can spend the rest of the class hours studying. Oh, that's boring. a lot of stuff I do as a dad is boring, but I got to do it, okay? Or a husband, whatever. I mean, it's just life. So, guys, you got to know these definitions, theorems, postulates, all of these things for your quiz tomorrow. And you've got to go back and review the homework problems in lessons 7, 1, 2, 3, 4, and 5 that are giving you problems. The ones that aren't, then don't worry about it. But the ones that are giving you problems, go back and review. Okay, notice this segment here has a length of 10. Notice this segment here has a length of 10. Well, they're congruent. They're both 10. So that means this point right here is smack dab in the middle of this side. Now, notice this segment here is 19. This segment here is 19. Thus, what that tells me is this point right here is right in the middle of this whole side right here. So, I have a line drawn inside the triangle that connects the midpoints of these two sides. That means this side here, this line segment here, the smaller one is half of this. So half of 27 is 13 and a half. Or if you want to use decimals, 13.5. Just use your calculator, type in 27 divided by 2. Or you can use 27 over 2. For all I care, it's totally fine. Any of these answers will work. They're all the same. All right. Please study for your quizzes. Email or call me if you have questions. You know I'm here to help you. And the only thing you have tomorrow is a quiz, so no notes, no homework over the weekend, and you will have a test next week. I tell you this, not every day, but at least once every couple weeks. If you got a call 706-965-MATH. That's a joke. 2675. Okay? And email if you need to. All right?